Hi, and welcome back to Rob's PC Workshop. Today I'm going to teach you how to identify equipment needs to meet customer requirements. So in this scenario, we've got owner of a small tier 3 ISP provides internet access to small business in the area. 10 customers are starting e-commerce activities and have inquired about co-locating their web servers in the NOC facility to provide faster access to internet backbone via the upstream provider. Because of the growing trend towards e-commerce, the ISP owner has decided to add co-location services to the services that they offer. So to connect customer web servers to the internet, the ISP must purchase new routers. The ISP is deciding between using several less expensive Cisco 1841 routers or one or two of the larger 2811 routers. You have been asked to evaluate which router model best meets the needs of the proposed co-location services and how many routers and interface cards are needed. The following requirements must be met. So the maximum budget for routers and interface cards is $10,000 for the first year. The starting configuration must support 10 customers. At least 20% spare capacity must be available at all times. If the spare capacity falls below 20%, new equipment should be purchased. A 20% growth rate in the demand for co-location services is expected each quarter or every 3 months. 2 serial ports must be available to connect to the upstream ISP to ensure the backbone routes are available. Each router needs to have its own connection to the upstream provider. So my task is to recommend the solution that best meets the requirements for the first year while staying within the maximum budget of $10,000. So for the purpose of this exercise, we're going to assume that the 1841 router is $1,500. The 2811 router is $2,500. Your HWIC 4ES 4-port Ethernet switch cards $500. WIC 2T to port serial interface cards $700 each, and the NDM ESW 161 16-port Ethernet switching network model is $1,500 each. So first thing I'm going to do is click the 1841 router in the workspace area. On the physical tab in the physical device view, click each module in the modules column and read the tab. This provides 4 switching ports. So which provides the most? This provides one port for connection to a standard telephone line, and the other port can be connected to a basic analog telephone for use when the modem is idle. This is a single port 10 megabyte Ethernet interface card for use with 10 base Ethernet LANs. This provides a single port serial connection to remote sites of a legacy serial network device such as a synchronous data link, concentrators, alarm systems, and packets over a SONET. The 2-port synchronous serial network module provides flexible multi-protocol support with each port individual configurable and synchronous or asynchronous mode, offered mixed media dial support in a single chassis. Applications for, again, asynchronous and synchronous support include low-speed WAN, aggregation, dial-up modem support, async or sync, connections to a management port of the equipment, and transport of legacy protocols such as BiSync and SDLC. This is just a cover plate, provides protection for the internal electronic components. It also helps maintain adequate cooling by normalizing airflow. So you can kind of see an idea of what the modules are going to look like in the back. This one provides 4 Ethernet switching ports, 2, 1, 0, 2, 0, and again just a cover. So as we can see, the HWIC4 Ethernet switching port is the most. So we're going to drag the module with the most Ethernet ports to the empty slot on the router in the physical device view. Okay. So we need to shut the power off on our router, turn the power off, put our ports in it. That gives us a total of 12, well, 8 ports on this one. So we're going to go ahead and turn on our router. So we're going to go to the 2811 one now that we've got this one configured. So we can see it has many more ports in the back. So we're going to turn the power switch off on this one. And we have a lot more options for ports here. So the NM ones are network modules. And the modules with the names that begin with HWIC or WIC are interface cards. So which network modules provide the most Ethernet ports? So you can see this one has one. I'm going to assume these network module 8AS. No, that's not it. There you go. There's 8 Ethernet ports as we can see on the 8AM. We're going to go ahead and go through all of them. 4 of them. This is 4 AS ports. This is 2 WAN interface card expansion slots. If you want to put that over there. This has 2. The name pretty much tells you. So we're gonna drag the network module with the most Ethernet ports to the empty network module slot on the router in the physical device view. So we notice the 8 has the most. Put that over there. So we have 4 empty interface card slots still. So we're going to go and see how many ports we can get on our interface. And I think we decided in the last time these are our most. So we'll go ahead and put 4 of these bad boys in this here. That'll give us 16 plus 8, 24 Ethernet ports. Go ahead and turn that on and look at that. We've got a ton of ports. Again, 24 available ports now in this computer. So hope that's been helpful. That shows you how to connect different interface cards and network modules into the back of a router, and the difference in the different interface cards and network modules. So hope it's been helpful. Have a nice day.